Alright, on to solving one-step equations by multiplication or division. Alright, I'm going to start this off kind of the same way we started off the addition and subtraction one-step equations, but same deal. If you do one thing to one side of the equation, you have to do it to the other side of the equation. So for instance, you can look in this example, they have 6 equals 6. Well, if I multiply both sides by 3, I'm still left with 2 equal sides, 18 equals 18. But again, I have to do that to both sides. Same thing if I divide a number. I have to do that on both sides too of the equation to keep that equality. So 8 does equal 8, but in order to keep things equal, I would have to divide by 4 on both sides if I still want an equal equation after that. Just showing that you need to, if you do one thing to one side, you have to do the same thing to the other side. Alright, so we're still going to use inverses here, and we're going to look at, find our variable, figure out what's happening to it, and go from there to try to solve for it using those inverse operations. Okay, so in A we have k being divided by -5, and multiplication is the inverse of division. So what we're going to do is, to undo division, we have to multiply by what is being divided. And I like to, whenever there's fractions, I like to put it over 1 so we can see what's actually happening here. Now if I were actually to take this and multiply this out like two fractions being multiplied, I'd have -5k over 1 times -5. But if I look this further, I could divide and reduce by -5. And we'd be left with, so -5 divided by -5 is 1, or just k, and then -5 divided by -5 is just 1, or k over 1, or just k. So we have successfully isolated that variable. Now that's why we multiply when a variable is being divided by something to get rid of it. So essentially what happens here, you won't have to show that every time, but if you multiply by -5, it cancels out with the division by -5, and we're left with k on this side. But like I said, we also have to multiply this side by -5 as well to keep that equality. So we have -4 times -5, which gives me a +20, and that should be our answer. We can check 20 divided by -5, that does come out to -4, so it all works out nicely. Alright, so that's how we do those. Same thing with B. M is being divided by 3, so I'm going to multiply by 3 on both sides. Those cancel, I'm left with M equals 1.5 times 3, 4.5. So that's how we do those. Alright, now for these two, we have a variable in A that's being multiplied by 7. So basically we're looking, it's kind of like a math facts question. It's really saying, okay, 7 times what equals 56? Well, we know 7 times 8 is 56, but to show that, we would divide both sides by 7. So you're really just finding the other factor of 56 when you know one of the factors. Same with letter B. Might not be quite as obvious, but we are multiplying W by -2. So I will divide both sides by -2. Those will cancel, and W is going to equal -6.5, or -6.5. That's how we do that. So since we're multiplying a variable, we will do the opposite of that, divide, in order to isolate the variable. Okay, last slide here. This is a little bit different, okay? So we've got 5/9 times V equals 35. So when we involve some fractions here, it gets a little different. I'm going to show you a couple different ways you can take care of this. So usually what students will figure out is, yes, since I'm multiplying by 5/9, what I have to do is divide by 5/9 on both sides. which is good. That's technically what you want to do. 5/9 divided by 5/9 will cancel, but remember when you divide by fractions, you're actually going to end up multiplying by the reciprocal. We're going to take the inverse of that second fraction and change it into multiplication. So really this is 35 over 1 times 9/5. And we can go ahead and solve this way. So shortcut, divide this by 5, divide this by 5. We have 7 times 9, which is 63, over 1 times 1, which is 1. So we're just left with 63. And you can go ahead and check that. Basically, fast way to check that, if you put 63 in for V, take 63 divided by 9, which is 7, and times it by the top number, which is 35. 7 times 5, alright? So some of you are like, well, can't I just take a shortcut with this one? Yes, you can. Because remember, you're just trying to isolate that variable. So if you know that multiplying by the inverse will cancel all these things out anyway, just multiply by the inverse right away, and you'll get the same answer we got before. Alright? One way that we can deal with B is to, well, there's a couple different options. We could do what we just did, essentially, multiply by 3/4 on both sides. Another way that I could write this is 4/3 y. The reason I can do that is because it's the same thing as 4/3 times y over 1, which brings us right back up to here. So 4/3 y is the same thing, but remember you want to isolate that variable, so we can multiply, oops, put that in the wrong spot, multiply by 3/4 on both sides. And we end up getting some cancellations over here. We're left with y equals, and then 15/8. Doesn't look like there's anything I can really do, so you can either leave that as 15/8 or change that into an improper fraction if you want to. So that's how we can go about that one. The only other thing that I would recommend, well, not the only thing, but at this point in time, the only other thing that I would recommend is you can multiply both sides by 6, the least common multiple between 2 and 3. And here's why. Because if I do that, I've got 6 and 2, so divide by 2. So I get 3 times 15, or I'm sorry, 3 times 5 is 15, or 15/1, which is just going to be 15. And then over here, I'm going to take divide by 3, divide by 3. I've got 8, or I keep doing that, I'm saying the answer ahead of time. 4 times 2, which is 8y, and then we can divide by 8 to solve for y, and we get the same answer, y equals 15/8. So that is another option. This is what I would call clearing the fractions. If you ever want to just get rid of all your fractions, that's one option you have. So that is one option. We'll talk a little bit more about that later. Looks like I have a student that wants to talk to me, so we'll see you next time.